Alright, this video is for the class Hands-on Fun with Rational Numbers. And in this video, I want to kind of review the things you need to know going into this class, okay? So this is a review video. I usually have one for every class. Obviously, I'm just making this one. And what we're going to go through is those facts you need to know for this class. So the class is broken up into three different sections: decimals, fractions, and integers. Okay? And then there's some bonus sections if we have time of ordering numbers, converting between these different things. But that's only if we get to it. These are the three foundational things you need to know to go into pre-algebra. So I kind of put it here. All these three things are the important things I want to get accomplished. So for decimals, the things that you have to know before going into this class, and this is for fractions too, for both of these, you need to understand these concepts, which are that less than 1, so that idea of less than 1. Okay, so we'll go over that today. Less than 1. Also, dividing with a remainder. All right, now so you need to know this, and you need to know dividing with a remainder. Things that are just, that are for both but different is modeling. So you need to be able to model a decimal, and you need to be able to model a fraction. We're not going to do modeling in this class. I might do it as an example, but the majority of this class is going to be looking at the arithmetic of it. You should already know how to model. Now for integers, the things you need to know is operations with whole numbers. You need to be able to do those operations with whole numbers, okay? All right, and when we do integers, we'll do absolute value, and we'll also do order of operation. So you should be familiar with most of order of operation. The only thing we don't do is exponents at this time. You'll find those in the pre-algebra class. So this is kind of the stuff I'm going to go over today, less than 1 and everything. So, and I'm going to be adding in layers of modeling as I go along. All right, so let's look at less than 1. And I'm going to model it too. Okay, so if I have the decimal 0.5, well, we should know that 0.5 is less than 1, okay? This is kind of like saying, I can add a 0 to the end of this. It's kind of like saying I have 50 cents. I don't quite have $1, right? I have less than $1. I have less than $1. And this is a very important concept. We have to understand that this is less than something, because when we divide decimals by decimals, we shouldn't get a whole number out, okay? Now, when it's a whole number and a decimal, that's a different story, and we'll talk about that in the actual class. All right, so if I was going to do this, I'm going to drop the 0 again. I have 5 in the tens place. So something you need to know to even do this is you need to know your places. Okay, so I'm just going to show you them on the next slide. But this is the tenths place, and we'll sidebar on the next slide for it, okay? All right, that's the tens place. So that means I have 5 tenths. I have 5 things out of a whole of 10. So if I was going to model this, let me draw my candy bar. I would color in, this would be my bar, and I'd color in 5 of them. And as you can see, this is less than 1. It doesn't fill up the whole entire thing. And we can do this idea, share this idea with fractions. Okay, let's say I have the fraction 1/4. That means I have a candy bar. It's cut into fourths. And I color in 1. Okay, this is less than 1 whole thing. I don't even have a whole thing, all right? I only have 1 out of 4. But to obtain the whole thing, I would have to color in all 4. So down here, I'm going to put 4/4. This equals 1 because my thing is cut into 4 pieces. I color in all 4 of the pieces. I've colored in 1 whole thing. So whenever I see 4/4, I should think 1. Okay. All right. Let's practice a few of those. Okay, so I want you to model. We'll start out with decimals first. All right, so what I want you to do, question number 1, and if you notice, I'm only doing the tens place because I don't want you to have to color more than that. So pause the video, try to do these 3, and then come back when you're done. All right, I'm going to assume that you've paused and that you finished the questions and you're ready to move on. I'm going to switch to an orange pen. All right, so this 2 is in the tens place. All right, so I know that it takes 10 to make a whole. And I keep saying, I taught my daughter this concept by using fake money. And I keep saying I'm going to get some fake money and I'm going to do a video showing what I did. And I haven't yet. But I think I really need to do that. So there's 10 pieces and 2 of them are colored in. So it doesn't matter how you draw your 10 pieces, just as long as there's 10 pieces, all right, and 2 of them are colored in, all right, and this is less than 1. It's not, the whole thing is not colored in, so it's not 1 whole thing. All right, in this one, you don't need the 0. You only need the 1, which is in the tens place. So again, I need to make 10 spaces. And only 1 is colored in. This is, again, less than 1. All right. This one's the same thing. The 4 is in the tens place. One, 2, 3, 4, 5. And I want to color in 4. And it doesn't matter if you made a circle, if you colored in slightly different ones, you could go and randomly color in your 4. It's just about, do I have 10? Is my thing split up into tens, and did I color in 4 of it? Okay? And this idea that the whole thing is not colored in, so I'm less than 1. Okay, so before I go on to fractions, I want to stop for a second and I want to do place value. See, I'm going in order on purpose. All right, we'll just do that much. All right. So this side is usually the easiest for people to understand. All right, let me make a grid and then we'll talk about it. So write down these numbers. You're going to need these notes throughout the class. We're going to be doing a lot with decimals. All right, so this is the ones place. So if I put my hand over the rest of this, the 2, 3, and 4, okay, you will see just a 5, okay? And that's like having 5 $1 bills, right? Okay, so if I move on to the next place and I only put my hands, I make it so that I cover everything except for the 45. Well, to make 45, I need 4 10s and 5 1s, okay? And then moving out, encompassing the 3. Well, to make 345, I need to have 3 100s, $100 bills, 4 10s, and 5 1s. And to make 2,345, I need $2,000 bills. I know there's not such a thing, but for the sake of conversation, that is what it is, okay? And you notice that every time I move 1, I'm adding a 10 to my place value. 1 looks like that. 10 looks like that. 100 looks like that. Look, I just added another 0, and then I add another 0 for the thousands. These are what we call our factor. And a factor is just a part of a multiplication, okay? Keep that in mind. We're going to be using that a lot whenever we divide decimals. All right, so when we get on the other side of the decimal point, the zeros start moving. Instead of behind the 1, they go in front of the 1. So let's name these. Well, if I name this ones, the ones place, it would be a whole number, because the place value, and we'll find this out when we go to convert, the place value tells me the bottom. So if it was 1, it'd be 6 over 1. Well, I can color in 6 different things when I'm modeling, and that would be a whole number 6. No, so we have to go to something that's going to be bigger than all the digits that can fit in there, and that is 10. And if you're working with fake money and you're working with the change, you would know that to make 67, I would need 10 dimes. Dimes are 10 cents each. I would need 6 of them, right? And I would need 7 pennies, which it takes, hold on, it takes 100 pennies to make $1. And then this last one, we're adding another 0 to the front, is the thousands. So watch. So where our zeros went to the end of our number, now they're going to go to the front of the number. And first we're going to start off with this place, 1 in the tens place. Then we're going to put a 0 in front for the hundreds, and a 0, 2 zeros in front of the 1 for the thousands. So you see, it kind of, you know, follows the same pattern. Okay, so you can almost guess what the next one would be. All right. Okay, so that's how that works. All right, and this is very important. So what I'm going to do, and I gave you this number pretty easily, I want to give a new number and ask you guys to find some of the places. So let's say I have the number 376.20. I can't use 3. I've already used 3. Let's say 4. All right, I want you to tell me what each one of these places are. Okay, and I'm going to erase this here in a second. So pause and tell me what all the places of this number are. Okay, I'm going to assume that you have already done it. You already paused and you came back. And let's look at what these places are. Well, the 3 is in the hundredths place. Okay, with an S. It's really hard. I've noticed my speech doesn't pop on my mic enough for you to understand the difference between hundredths and hundredths. But I am saying two different words. The 7 got to decrease by a factor of 10 would be the tenths place. So the tens place. And the 6 is the last one, it's the ones place. Alright, on the other side of the decimal, these are my less than 1 values. Just put my A and my L together. And I have 2, which is in the tens place. Remember, we don't start with the ones. No such thing. And then going over one more would be the hundredths. All right, so that was a good little, sidebar teaching. All right, but we need to get back to fractions. So hopefully you understand your place values now. If you're still struggling, let me know. I'll give you a video, another video. All right, so back to the fractions. I want you to model these 3 fractions. Okay, so 3/4, 3 over 3, and 2/5. Model these fractions. All right, I'm going to assume that you have paused and you're back with me. And I'm going to start modeling these. All right, so there's 4 pieces, right? And I'm going to color in 3. I didn't color in the whole thing, so this is still less than 1. And it doesn't matter how you draw your model as long as there are 4 different parts to your model and you color in 3 of them. Now in this one, I have 3 parts and all 3 are colored in because the top number tells me how many are colored in, and we'll sidebar and talk about the parts of a fraction here in a minute. This fills up the whole thing, so this one is not less than 1. This one is 1. Okay? Now, this one, we have 5 spaces. Two of them are colored in. It's still less than 1. It doesn't color in the whole thing. So let's talk about the different parts of a fraction. I'm going to use this 2/5 as my model, but I'm going to put a 1 in front. Say it's 1 and 2/5. Okay? And let's talk about the parts of a fraction. This 1 is the whole number value. Okay, this is the part that is more than 1. Okay, it's 1 or more. I should put 1 or more. Okay, 1 or more than 1. All right, this is what we call the numerator, and I'm just going to put that so I don't have to write for a year. It's a long word. We also call this the part. It's the part that I shade in, just like in all of these. The number on top told me how many to model that were shaded. Okay, this bottom, a lot of people call this the whole. and it is okay if you call it the whole, but don't confuse it with the whole number, okay? This is the whole parts that make one. All right, what I tell people, my students, is think of this as its place value. Okay, just like when we were modeling decimals, we had to make them all out of 10 because that was the place value. When we model fractions, we do the same thing. The 5 tells me how many pieces I have. It's like my place value. All right, and this particular number is called a mixed number. Okay, because it's a mix of whole numbers and parts of a number, and fractional parts of a number. There are other types of fraction, and I want to go over those. An improper fraction is when the numerator is bigger than the denominator. Oh, by the way, this is the denominator. So like in this example, this is bigger. Okay, this is called an improper fraction, and actually we could make this into a mixed number if we want, and that's actually part of the class. I actually show you how to do that as part of the class. If you know how to do it, that's awesome, very awesome. Make sure you tell me when we get there, and I'll let you kind of lead what we're doing. But for this particular class, I kind of teach that because it's kind of important to me to teach that concept of a mix of whole numbers and parts. Another one is called a proper fraction, and a proper fraction is just the fractions we've really been working on today. A proper fraction is when the numerator is less than the denominator. Like in the fraction 2/5. This is a proper fraction. All right. Okay, so that's kind of the stuff you need to know. Let's go back to our review. We've done these two things. I'm not really going to do operations with whole numbers. You should know those. We are going to do dividing with stuff that's going to give me a number, a remainder. So we're about ready to go into that. I'm not really going to do operations with whole numbers in this video. I want to assume that you know it. But that's something you need to know before we get to integers. Okay, but that's the last topic. So if you're rusty on your operations with whole numbers, you need to contact me the first day so I know to do a little refresher before we get there. All right, so let's do some dividing of numbers that will have a remainder. Okay, so in this one we're going to do some divisor problems. I'm going to start out small. So in this first one that I'm going to do, here, let me find a good one. We're going to do 4 divided by 36. Now, if I were to write this in a different manner, I could have written it like this, and I would have had to know that this first number goes inside the divisor hat, and this one goes on the outside, okay? So 4 goes into 36 9 times, right? And if I want to know how to do that quickly, I could do 9 times 2. Everyone knows 9 times 2 is 18. And I could double it, which means adding it to itself. This isn't a method you have to use. It just helps, okay? And if you have trouble with your division facts and everything, please email me now. I can give you a whole packet on division facts and whatnot. All right, so that's just one. Really easy. Get yourself all warmed up with it. Let's do some harder ones. Okay, just showing you where the numbers go and everything. I didn't want to do anything too distracting from seeing where everything goes. So, in this one, okay, sorry. I thought I had it all lined up which packet I was going to do. I guess I didn't. We're going to do a few. Whenever you divide a number, okay, like this 8 into this 573, I don't want to look at the whole 573. That would be overwhelming. How many times did that go in it? I want to go by each place value. So first I'm going to look at the hundredths place of the 573. Okay, so the hundredths place is right here. This is the hundredths place. All right, can 8 go into this 5? Well, no, it can't go into this 5. I can't put 8 into 5. So we have to fill in every single place value or we'll get off for what we're doing. If you don't do this one, it's not a big deal, but I want to show you with doing it just to make sure we stay organized. Okay? And then I need to drop down the next place value, which is the tens place. Okay? This 7 is in the tens place, so I need to put a number in the tens place of my answer. So how many times can 8 go into 57? Well, that's 7 times, because 7 times 8 is 56. If you need a multiplication table, let me know. Okay? I'm not a big fan of using those in class, but I will for the sake of it not slowing you down and keeping you from learning what my class has to teach you. So let me know and I can get you one. The next thing we want to do is subtract. If you have done long multiplication, you know that you add going down. Well, division is just the opposite of multiplication, so we subtract going down because that would be the opposite of adding, right? So 56 from 57 is 1. And then I need to drop down my ones place. Okay, this 3 is in the ones place. So I'm going to drop it all the way down here, and I have to put an answer in the ones place. So 8 goes in the 13 one time, which is going to give me 5 left over. So I'm going to put remainder of 5. All right, let's do another one of those. All right, 5 cannot go into 3, but I don't really have to write a 0 there. I only suggest you write a 0 there if you tend to be sloppy, okay? I'm going to go over this time to the 32. 5 can, I know that 5 is not going to go into that 3, so I'm going to have to take 2 place values at once, and I have to put the answer in the last one. So my answer is going to go in the tenths place. So 3 goes into 32 6 times. See where I'm putting this 6? Which is 30. And if I subtract those, I get 2. Drop down my 8. 5 can go into 28 5 times, which is 25. If I subtract these, I get 3, remainder of 3. Okay, so this requires you to know those multiplication tables. Again, let me know if you need a multiplication chart. That's between you and your parent if they're going to allow you to use one. All right, I'm going to give you a few problems to do, and you can pause this video and do them and get back to me. All right, so pause for a few minutes, do these, and then come back and I'm going to do them. All right, I'm going to assume that you have done that you have done the problems and have come back to me, and I'm going to do some. So 9 goes into 12. I'm just going to look at these two first. 9 goes into 12 one time, and that's going to give me a remainder of 3. All right, now 9 goes into 38 4 times, because remember that's 36. And I'm going to get a leftover amount of 2. 9 can't go into 2, so I know it's going to be a less than 1 situation. So it's a remainder of 2. 14, remainder of 2. All right, 7 can't go into 6, so let's look at 65. Well, 7 can go into 65, and that's 9 times, which is 63. 9 times 7 is 63. All right, if I subtract those, I get 2. Drop down this 3. 7 can go into 23 3 times, which is 21, leaving me again with a remainder of 2. So this one was 14, remainder 2. This one's 93, remainder 2. All right, now 2 can go into 9 4 times, which is 8. Subtract and get a 1. 2 can go into 11 5 times, which is 10, giving me a remainder of 1. So 45, remainder of 1. All right, if you're having trouble with those, let me know, and I can give you some worksheets or more videos, but that's basically in a nutshell the things you need to know how to do before starting this class. All right, like I said, we're going to be going over decimals, but I'm not going to model them, okay? Maybe for an example, but we're going to start moving into an arithmetic way of doing decimals and fractions, because we can't be spending all that time modeling when we get into integers. It will take us way too much time to do our problems if we're modeling everything. So we have to start getting towards that. So make sure you can model, though. It's a good foundation for what we're going to do. Make sure that you can divide and get a remainder. Make sure you understand the concept of less than 1. And make sure, even though I didn't do it, make sure you know your operations with whole numbers. If that's something that you're having trouble with, I can give you a worksheet and a video to help you before we get there. All right, I can't wait to meet you in class. Bye.